Welcome to the Real Python Podcast. This is episode 192. What are real-life examples of using Python decorators? How can you harness their power in your code? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We discuss a recent article series that digs into Python decorators. The first two articles discuss the basics of constructing decorators, and the third part describes how popular Python libraries use decorators with call interception, function registration, and enriching the behavior of a function. Christopher shares a piece about the common pitfalls of working with the Python datetime library. The article considers how current third-party libraries don't address most of these quirks and offers a potential solution with a new library. We also share several other articles and projects from the Python community, including a couple of news items, a discussion about the popularity of the Rust language, handling unset values in FastAPI with Pydantic, working with Python's mini-language for formatting strings, mocking Django-Queryset functions, and a modern replacement for the request library. This episode is sponsored by Sentry. Learn about the upcoming workshop, Taming the Kraken, about managing a Python monolith with Sentry, or find out more now at sentry.io/resources to register. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back to the show.
Hey there.
All right, so we have some news to start with. Couple topics each and a discussion. This one actually kind of predicated by somebody sending in an email to podcasts@realpython.com. We'll talk a little bit more about submitting your own questions or potential discussion topics later. You ready to go? You want to start with the news?
Sure. I think our listeners should send us something that makes you and I argue. Could be their challenge. Find something we don't agree on.
All right. It would only be video games and movies or something.
Could be. All right. So news. We've got a couple releases or a couple series of releases. There's been a security fix for Django having to do with a denial of service vulnerability in the int comma filter. So go get your 5.02, 4.2.10, or 3.2.24 if you want to fix that. And second, also a bug fix release is for Python 3.11 and 12, which brings us to 3.12.2 and 3.11.8 if you're counting. And the final piece of news is the Python Software Foundation's grants program has announced that they're going to start holding office hours. There was a bit of a fuss a few months back having to do with a bumpy grant process for DjangoCon Africa. And to help prevent future communication challenges, they're going to start holding office hours. The hours will be on the PSF's Discord at 2 p.m. UTC, and that's on the third Tuesday of every month. Links to this announcement are in the show notes. So if you're involved with conferences or want to better understand how grants work connected to that, this would be a great place to get quick feedback.
Yeah, it's been we've been talking about the communication channels with the PSF have been sort of opening up, especially with them bringing on all these additional sort of in-residence roles and so forth. And it's good to see that happening here with the grants programs. Communication is great. I like this direction. First topic, I'll start here. And my tutorial, the first one here, is by our friend Leodanis Pozo Ramos, and it's titled Python's Format Mini Language for Tidy Strings. This is a very detailed tutorial about string interpolation and the formatting of those interpolated values. It's intended or kind of directed toward intermediate Python devs. But if you're a beginner and you're interested in printing strings and formatting the outputs of like F strings and so forth, I think you might find this of interest. You may not be able to dive through it all in one sitting, but it's a really great reference. Lots of areas that could be referenced later and something we can come back to. Leidos starts out by briefly covering sort of the three popular ways of doing strings and sort of the interpolation of them, kind of in reverse order, I feel like, for popularity, but historically they were the ways they were originally laid out. The first was the modulo percent operator, then came the string.format method, and then the one that's, in my opinion, the most popular today is the fstring and fstring literals. And so he talks a little bit about that. And then he actually kind of does a lot of explanation through discussing how the Python docs show this stuff. And so that gets him into briefly discussing this idea of backus nar form or BNF notation. And I'll include a link to the Wikipedia article about that, which gives a good example of how you kind of can look at that syntax. It's something that's, I guess, popular in explaining rules inside of a language. They use an example of how addresses might look in the Wikipedia article, and how even though you don't necessarily use all of these components in every single address, this is where these things go and what order they should be and kind of the rules there. And that's kind of the idea here. This grammar, if you will, gives you an idea of it. So he's using that to kind of give you an idea, because this formatting has a very specific grammar. In the case of string.format, you end up with opening with your curly braces, and then from there you can have an optional field name. It's not a required thing, but after that you then can have a exclamation point, which is called sort of a conversion field. It's used most commonly when you're doing like object-oriented types of things to be able to call out these couple dunder methods that we've discussed before on the show, the dunder str or dunder string and dunder repr, the REPR. The string one is sort of the user-friendly, readable to an end user way of showing what an object is, it printing out in that way. And then the repr one being a lot more developer friendly. It usually includes the details for recreating an object. So if you're not familiar with that, he's got a link to a previous tutorial that digs into dunder string and dunder repr and can kind of explain some of that there. So there's this exclamation point S would be to call it as a string, or exclamation R to call the repr on it. To me, those were a side note, but this is, again, going systematically through everything. In my opinion, the more interesting part of it is when you get to the part where there would be a colon, which is for this formatting spec. From there, that's where you start to learn about the ways that the content that could be included within those curly braces can be formatted out. And so this is where he digs into the next one, which is for F strings, which for the BNF grammar for that actually has 5 different things. So if you're familiar with F strings, at the beginning of this string literal, you type F and then you open your quotation marks. And as you type out your string, you could put in curly braces. Inside the curly braces, you could put the name of an object to have it be replaced and formatted literally right inside the string, which is very nice. And so that's the first thing that can be part of that, the expression that can be put inside of it. There is an optional equal sign that can come next if you want, which is something that was put in for sort of troubleshooting, allows you to very quickly show the value of something inside of an F string. If you're not familiar with that, there's a link kind of explaining that concept. And then the 2 other things that we covered before, the exclamation point for conversion. So you can do exclamation point S or exclamation point R. All these things are little optional things you can put in outside of the F expression at the beginning of it. Then you get to the part that you may have seen before, which is a colon and then your formatting spec. And so this is where you dig into the part where it's like a really good reference. So repeating the BNF grammar here, he's actually getting into like, okay, what are all the different types of things you can do when printing out these strings? So you can have a fill. You can choose what character is going to fill in the blank space when working with another optional thing, which is the width. You can choose to align left or right. So as you're printing out something, you could say, I want everything to be filling out a column that's 10 characters wide, but I want everything centered, or I want it pushed to the right and left, using your greater than, less than, or caret symbols for those. You can have, if it's numbers, you can have the sign on it. Again, you can choose the width of that column. You can choose grouping, and then precision of decimals. You may have seen like colon 0.2f for indicating that you want to have 2 decimal places for your floating points. And then at the end of it, you can have a type, which includes binary, character, like Unicode, decimal, octal. So it digs into all that stuff. So again, a really great reference piece, letting you see all those things, lots of examples showing off the techniques being printed. And then he talks a little bit about some other things that sort of fit in here. Thousand separators, you may have seen using a comma or an underscore. There's an interesting way to plan in advance that he covers, which is formatting the fields dynamically. And then a couple more practical examples, like how this might look if you're wanting to print out receipts. Again, using something like the fill and the width and the alignment, working with dates and their different sort of symbols that are in there. So it's a great guide for this literal string formatting thing. If you've worked with F strings before and maybe seen that colon in there or that exclamation point in there and kind of wonder what's going on with that. Well, that's all part of this grammar for working with these string formatting. Do you use any of those additional things? Do you use the exclamation point R and S and stuff like that?
I use the equal sign when I remember it's there.
Yeah.
The formatting stuff comes up rather frequently. Actually, I'm in the process of building a course right now where I'm having the students print out tables to the screen. And so having sort of column data and tables in a text format, that's very useful for that kind of thing.
Yeah, it's nice.
If anyone's interested and they want to dive deeper into that whole parsers and BNF spec as stuff, there's also another one out there called Antler and a Python library called PyLasso that works with that. It's a little easier to use than BNF, and there's an upcoming article that's going to be linked in a PyCoders, and we can include a link to that in the show notes as well.
Yeah, I think Lay It Honest is actually, I think partly why he focused on it for this one is that he's got an upcoming article on it too that we might be talking about both of those soon. So what's your first one here?
My first article is by Ari Bovenberg, and it's called 10 Python Datetime Pitfalls and What Libraries Are Not Doing About It. The not in the title is in brackets, so it's implying the libraries are and aren't dealing with the pitfalls, and I'll get to that a little more in a second. Ari starts out by explaining what he considers a pitfall. These are behavior issues, not bugs. So behaviors that are surprising or confusing and mostly caused by the fact that we're dealing with designs from 20 years ago when computing didn't worry so much about the wider world. For each pitfall in the Python built-in module, Ari also covers whether the same pitfall exists in some of the more popular third-party datetime libraries like Helicopter, which is just so fun to say, Arrow, datetype, and Pendulum. So the first pitfall discussed is the fact that datetime has 2 incompatible concepts squeezed into the same class. A datetime instance can either be naive or time zone aware. And this results in the problem that you can accidentally mix the two, ending up with bugs. And as it's just one class, you can't use type checking to figure out whether or not this solves the problem because it's either of the datetime type or it's not. You can't tell whether it's datetime and naive or datetime and aware. Helicopter and datetype both use separate classes for naive and aware situations, but Pendulum and Arrow don't. So this is, you've got the pitfall in the built-in. You've got 2 third-party libraries that handle this and 2 third-party libraries that don't. So it's a mix all the way down. Pitfall number 2 is the fact that the plus and minus operators on a datetime object don't take into account daylight savings time. This one surprised me. I wasn't aware of this one. So if your addition or subtraction is over a daylight savings boundary, you're going to get the wrong answer. So,
nice.
Midnight the night before daylight savings time plus 4 hours will give you the wrong time because you lose your hour at the daylight boundary. And that's great. The third-party library Pendulum does handle this one correctly, but the other 3 don't. They have the same issues as datetime. So dates and times are fun. And if the concept of naive and aware isn't hard enough, to make matters worse, there are variations on how naive is handled. In some places in the Python standard library, a naive date time is interpreted as being the local time. And in other places, it's treated as UTC. And in still others, it makes no assumptions about the time zone at all. So if you get the answer out of a certain method and then try to pass it into a different method, you might get it actually shifting the time zone on you and you wouldn't be aware. Our 4 industrious third-party libraries, well, Pendulum and Arrow discourage the use of naive objects, but they still have the same kinds of inconsistencies that the datetime module has. Datetype and Helicopter don't address the problem at all, so going third-party here doesn't fix this. The article goes on. It's got 7 more pitfalls on top of that. And I'm just going to put this out there. We missed an opportunity in the Python community. We could have fixed this when we did the big breaking changes from 2 to 3. Date time could have been made backwards incompatible for the same reasons that strings were. You get rid of ASCII, you can get rid of single time zones and, have a little more of a perspective on the rest of the world. But alas, it wasn't done. And so we're still dealing with this historical mess. Maybe changing this library would have caused a fuss with the 2 to 3 switch, but I'm sure it went so smoothly otherwise that no one would have noticed.
Yeah.
Snarkiness aside, this article is a good reminder about how messy dates and times are, and finishes up with a nice summary table showing you the 10 pitfalls and for each how the 4 third-party libraries deals with them. The article reminds me of another one called Falsehood Programmers Believe About Time, which really should be seminal reading for all coders everywhere, and we'll link to that in the show notes.
I saw something recently where it was like, everybody should go back and look at this reference from time to time. Like it was sort of misconceptions that it's like a whole Wikipedia article.
Yeah.
And I feel like this is one of those that's the same.
There's 4 or 5 popular falsehood programmers believe articles, and they're from different people. It's just sort of become a pattern that certain programmers have written about. Date times are one of the ones you definitely have to worry about. The other one, which I find most Western programmers completely ignore, is names. And because in North America, it's very much sort of a first name, last name, and well, the rest of the world isn't there. And so, that can get pretty messy as well. And currency is another one, right? And these are all things that are relatively easy to code with if you design with them up front, but are very difficult to code with if you have to go back and retrofit it. And the entire Y2K problem is based on that, right? It's like, oh, well, 2-digit year, no problem. And if we just started with 4-digit years, it never would have happened, right?
Yeah, it's kind of like that BNF thing we were talking about earlier when they were given that address example. The name is part of that. And there's these subsections. There's the friendly personalized name part of it, and then there's the actual surname and so forth. And each of these can have all these sort of modifications in it. So as long as you have the structure for it, right?
Yeah. Well, and you run into it a lot with email addresses.
Right.
So I've got a couple funkier email addresses with characters that websites will disallow on a regular basis. And it's like, oh, this is a legal email address. Look, I can send myself email. It arrives. But you're not letting me sign up with your form because you've used a stupid regex that isn't actually aware of the entire rules around email addresses. So, yeah.
Yeah.
Fun.
Easy to reminders to check these things from time to time. You know what's hard? Managing a Python monolith. You know what helps? Sentry. Join David Winterbottom, Principal Software Engineer at Kraken Technologies, as he sits down with Sentry to talk about how his team of 500 developers are able to develop, deploy, and maintain a rapidly evolving Python monorepo with over 4 million lines of code. Woof. In this workshop on February 28th, you'll learn how to find and fix root causes of crashes, ways to prioritize the most urgent crashes and errors, and tips to streamline your workflow. Go to sentry.io/resources. That's sentry.io/resources to register for the Taming the Kraken workshop on February 28th or on demand in March. If you can't make it, register anyway to get a recording. The next one we have, it's from our friend Bytecode. That's spelled Bite. So this is a three-part series about decorators. In fact, he kind of cleverly calls it Xmas Decoration Part 1 in the first part, and with a little subtitle, Binary Trees or Trees 2. And that one came out on December 24th. And what's kind of funny is it's stretched out now all the way into late January. So it's not quite so much the Christmas season anymore, but he still kind of kept the theme at least. Decorators, I've said, I don't know how many times now, that this was an area of Python that I feel a lot of beginners, and definitely myself, I would see the @ symbol that would indicate that something is a decorated function and scratch my head. What is going on here? What's happening with this? And I feel like a lot of people go through that moment. And his first line of the article is, every Python dev will go through the moment where they need to learn about those damn decorators. And I'm like, yeah, it's a very, very common thing. And hopefully through me describing it here and you kind of digging through the articles, if you're interested, you can learn a little bit more about what's happening with them. And I like that he's divided it up. The first part is an introduction to it and give you an idea of like, well, what's happening? What's the key idea of a decorator? One of the things that I need to get a bell maybe on the side of my desk here that allows me to just ring it every time we say everything in Python is an object. Ding. A function is an object. And what's interesting about that is a function can be passed as a parameter inside of another function.
Wrong button. I was trying for...
There you go. There's our new sound effect. The angelic. Everything in Python is an object. The other thing about functions is that you can define them dynamically. And another interesting thing is that you can return a function from a function. So lots of interesting kind of ideas that are a little advanced if you're not familiar with that. And so this first one gets you up to speed, shows some examples. Ger Arne, who I've talked about multiple times on the show and was our first guest on the podcast, we talked about decorators in our first episode, and I made a video course based upon his really great, very detailed primer on Python decorators. So I'll include a link to that also in case you'd like an additional resource there.
He loves those. Every time we do the Python updates, he's always like, I'm taking the decorator stuff. I'm taking the decorator stuff. I have to, I wouldn't even try to win that fight. It's always him.
He's a big fan. Yeah. Through the piece, you get the idea of, okay, a function can be wrapped around by another function. It can have code that runs sort of before the original function, then runs the original function, then have code that runs after it. And gives you this idea of, how that kind of works, the idea that a function, again, can take a function into it as a parameter. And the first part ends with adding the syntactic sugar of the @ symbol there. You might have been left with a bunch of questions, so part 2 digs into what if. And the first one is, well, what if you got parameters and you want a return value and so forth? And how do you pass parameters into that decorator? And what happens to the repr and what happens to help? Why do they stop working with the decorated function? So this second one really digs into that stuff. Lots of examples in code showing you how to send not only parameters, but keyword arguments inside of it. It shows you how to do that with the star and the double star. A lot of these ideas may seem really interesting, but you might have this last question. That's what part 3 is about. Well, what do you actually do with this stuff? What's the point of it? And how are they useful? Or where have they been used? Again, this one came out January 21st. Part 3, titled Xmas Decorations. Part 3, the title is aging so well. He gives cases now. Okay, here's what you can do with it. So the first example is you can have it do an intercept of the call of the function. So it can do a check for the original function that you're decorating. If the check is passed, then you don't even execute it. As an example, in Django, there's checking if a user is authenticated. There's a library we'll talk a little bit more later, Pydantic, which is a validation library. It has a decorator that checks a function's input and raises an error if the input matches that, basically the type hints are defined.
In the Django case, it wraps the function that outputs what's on the page, which is called a view. So what it does is it puts you behind a security wall. So if the view is supposed to be secure and the user's supposed to be logged in, then they get the page. And if it isn't, it sends a redirect to the browser. And so then the browser gets the redirect, sending them to the login page. So that essentially, if they haven't been logged in yet, they go to the login page. And then once they've logged in, the login page forwards them back to the page you were on, and it lets them in. So that allows you to not have to put login logic in every single one of your pages. You just put the decorator over the top of it and let the framework take care of it for you. So it's a great example of that sort of interrupt it and check a permissions level thing.
Yeah. So again, this idea of wrapping around a function with this sort of code that you would want to repeat often, this really represents the whole do not repeat yourself dry kind of concept really well inside of Python. This idea of, I can add authenticated or whatever at the beginning of it, and it's going to do all this logic for you, intercepting the call for you. He actually writes some code to create an example for rate limiting. So you could say, I want to cap the number of calls per second, again, sort of intercepting how many things can run at a time. In Garana's tutorial, he has something similar that allows you to delay something. You can say, maybe you don't want to overwhelm a service, online or otherwise, allowing you to control stuff inside there. And it's something that, again, you can add or remove pretty easily with the code, with just this @ symbol, which is really, again, a nice way of sort of working. His second example or case gets into registering of functions. Sometimes a decorator doesn't really make a wrapper around the function. They're just returning that original function. You want to pull it out. So the other popular framework that we talk about often here, which is Flask, you might have seen this sort of routing feature using the @ symbol and decorators there. And it's registering URL paths with endpoints and allowing you to direct your code that way. PyTest has a feature using decorators for defining fixtures. And he provides another nice code example there with an example of how to do the registering. And in Garana's tutorial, he gets into this idea of like sort of a plugin architecture, which is a very similar kind of idea. The last example he gives, or set of examples he gives, is this idea of enriching a call, adding additional functions or behaviors to a function. You can have a function that retries if it fails. Talks about a library called Fabric that is for deployment, and it can configure deployment, such as telling the host where this should run on. If you're interested, last week I had Savin Goyal on from Metaflow, and Metaflow is a system that's all about decorators. They just added two @PyPI and @Conda decorator that basically make sure that you have the needed dependencies for those particular sections of your code. So you can say, okay, this should be via PyPI. It's going to use these particular requirements and so forth. So kind of a neat way of, again, adding functionality to something with this nice way of decorating everything.
Way back in episode 125, we talked a bunch about LRU cache, which is done the same way, which is in part of the standard library. And you wrap a function on it, and if the second time it's called, it'll return a cache value instead, giving you performance benefits. So this technology is used even within the standard library.
Yeah. The other one that he kind of ends up wrapping up here, kind of showing you the idea, is this idea of creating a really common example in the decorator world of creating a thing that can time your function, creating a classic timing decorator. He wraps up the whole series here, talking a little bit about libraries that use all of these things. So he talks about this library called Click, which is a CLI library, which is really powerful. And it does all the above. It has stuff for enriching the calls. It has registering the functions. It has things that are, again, intercepting calls and determining logic based upon that. So I think it's a really good resource. I like that there's so many examples that are kind of tied in there together. And then again, also calling out all these additional libraries and stuff that are using them. So if you see decorators out in the wild, I think this is a good series to kind of get you familiar with some of the concepts there. And if you want another take on it, you can definitely check out Garana's guide, or I did a video course on decorators also that can give you a good introduction to them. All right. So speaking of Pydantic, which I mentioned briefly there, what's your next one here?
Yeah, this next one is for me. It was sort of an article of bad timing. I read it a week after I ran into the same problem.
Oh no.
Which of course isn't the author's fault, but it was sort of a Murphy's Law kind of thing. I'd wish I'd read this article a week earlier. It would have saved me a bunch of time. Anyhow, it's called Handling Unset Values in FastAPI with Pydantic, and it's by Roman Imenkolov. I wasn't actually using FastAPI myself. I was using Django Ninja, but it's heavily influenced by FastAPI's design, and like it, uses Pydantic, so it has the same little quirk. So before I dig in, a little bit of background. REST is a common protocol for communicating data back and forth with a server. It uses HTTP methods to describe the action you want to perform, and then the URL inside of it indicates what piece of data you want to interact with. So sometimes they call the HTTP methods the verbs, the what, the action, and the URLs, the noun. Then inside of the actual HTTP body, the payload, is where the data itself gets sent back and forth. So let's say I've got a person object on my server that has a first name, a last name, and an email address. The base URL to address a person might be something like /API/person. When someone uses REST to talk to that URL, the person object represented in Python on the server gets serialized into a data format, typically JSON, and added to the body of the HTTP request, which sends it down to the client. So HTTP has different methods, and the various methods indicate the action you want to take. Your browser commonly uses two HTTP methods, get and post, and get being the thing that fetches a page, and post is what your browser uses to submit a form. In REST, get is used to fetch data, kind of like fetching a page, and post is typically used to create a new object, kind of like when you're submitting something to the server. So back to my example. I've got a person. I run get on /API/person/42, and that would fetch the person for ID number 42. The response would contain a JSON dictionary with fields for the first name, last name, and email. To create a new person, I'd post using only the base URL, no ID number, and sending a JSON encoded dictionary with the fields describing the new person. A post call typically responds back with the same data sent plus any new data that got added, like that person's ID, so that it could be used in a future call. So great. So I've got HTTP, get, and post, but there are other methods as well. In fact, it has two methods that REST uses for editing data. The put method is used to edit information, but expects all of the information to be there. So if I call /API/person/42 with put, I send up all the person's fields, first, last, and email. And then the server would replace the current person number 42's data with whatever I sent. The other method is called patch. Unlike put, patch only needs the thing that was changed. So this means you send a lot less data up. You only have to send the field that changed. So if we're editing the person's first name, with put, I have to send everything. With patch, I only have to send the first name. All right, so all that's the background. This leads to the problem. Pydantic gives you the ability to define classes that determine how serialization works. So I can create a Pydantic class that indicates I'm creating a person with 3 string fields, one for first, last, and email, and an integer field for the ID. FastAPI or Django Ninja then uses Pydantic objects with the REST calls to turn your class into JSON or your JSON into a class. Ninja takes that a step further because it's built on Django. It uses the Pydantic object and can even translate it down to a Django database model as well. So this is all connected to sticking stuff in your database and getting it back. Now, here's your actual problem. In Python, if a field is empty, you set it to none. If I'm using the put method, none means the field on the server should also be none. But with patch, I have a problem. How do you distinguish between a field that wasn't sent by the client and one that was set by the client to a value of none? In both cases, Pydantic has nothing to put in the field, so the attribute ends up being none. So I know it's a little wrap your head around that, but back to my person example. If I'm patching and I'm only filling in the first name, I'm trying to edit the first name, the Pydantic class will have that in the first name field, but it will still have a last name attribute and it will still have an email attribute, which it sets to none. Well, what if I wanted to set the email to actually be empty? Well, I can't use none because it's being used for something else to mean the field wasn't edited, and this just sort of gets into your problem. So when I ran into this in Ninja, I got around it by adding some code that directly inspected the HTTP body and checked what fields were there and added some conditional code for this case. Turns out I could have done it in an easier way, and that's what the article's about. Pydantic objects have an attribute that explicitly say which fields were set, and it's different in Pydantic 1 than 2. So in 1, it's called dunder field set, kind of logical, and in Pydantic 2, it's called model field set, so close enough. There's also an exclude unset argument that can be passed when calling the two dictionary methods on the Pydantic object. So there's all these neat little references in there that could have got me around this problem. Hence why I wish I'd read this article a week earlier. I'm not really a Pydantic guy. I use it because of Ninja, so I didn't even cross my mind to go into Pydantic to look for a solution here. I was looking to solve the problem in Ninja. So if I'd gone one level down, or if I'd come across Roman's article a week later, it would have saved me a whole bunch of time. But if you're interested in REST and HTTP and puts and patches and all that kind of good stuff, this kind of dives into one of those weird little corner cases that you don't necessarily think about when you first learn about this stuff.
Yeah, it sounds like a resource that can help a few others out there.
Yes.
Running into the same thing, yeah. This week, I want to shine a spotlight on another Real Python video course. It's about a topic we touch on this week, and new students to Python can often find a bit confusing. It's titled Python Decorators 101. The course is based on a Real Python guide by previous guest and Real Python team member Gerarna Hiela. It's a course created by yours truly, and I take you through how functions are first-class objects in Python, how to return a function from a function, how to create simple decorators, applying the syntactic sugar when using decorators, how to decorate functions with arguments, and you'll practice creating several real-world examples of decorators, including timing your functions, debugging code, slowing down code, and a plugin registering system. I think it's a worthy investment of your time to learn how to use decorators and to recognize how decorators are being used in all the code you encounter on your Python journey. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. All right, well, as I mentioned at the top of the episode, that we have a discussion this week, and it's based on an email that I received, and this is from listener Steven. He wrote, I need a sanity check. Is it just me, or is Rust being overhyped? I can see where it can be useful. I use C when appropriate, C++ when appropriate, and Python is like the Swiss Army knife that allows me to do so many things quick and easy. I took a peek at Rust, and my initial thought was meh. The hype kind of reminds me of the Ruby on Rails a few years ago. I had the same meh thought. We decided to gather a bunch of resources. We definitely have mentioned Rust a lot on the show. I have said, I don't know how many times, that the most common thing when I've asked guests, like, what do you want to learn next? And again, it doesn't have to be about programming. That Rust is the thing that always seems to come up. So with a certain subset of programmers that are doing Python projects and are potential guests of the show, I would agree that Rust is a very popular tool. As far as the sanity check part of it, I don't know about the overhyped part of the question there. I know it's growing. The popularity's there. I don't know if you, as a Python developer, need to learn Rust. And what's kind of nice is you don't necessarily need to learn it to get all the advantages of it. So what we've included is a bunch of additional resources here that touch on this. One is an article by Slater Stitch, which is titled The Python Rust-Aissance. So kind of like Renaissance, I guess, right? So it talks a lot about Rust replacing C as the backend workhorse language for high-performance Python packages and discusses the why. It actually has a few interviews with a lot of the developers that are choosing it as a package. We've mentioned the Polars libraries. He got some comments from Richie Vink And then there's a project called Lance, which is a low-cost vector database, high-performance vector database. Rough, which you mentioned multiple times, which is a very fast Python linter that's written in Rust. Rough is created by Charlie Marsh, and he goes pretty detailed into like reasons why. And then Pydantic, which you've mentioned a couple times now, is a developer-friendly library written in Python. They decided on their team to rewrite their version 2 in Rust, and they saw a 20 times performance improvement. So it's one of these things that it's coming up very often for, I think, developers of tools and packages that need to run fast, especially in the data world where we're dealing with lots of stuff coming in and out. Also in the numbers world, things like, NumPy and so forth have always been written in these lower level languages that if you need something to go quickly, these are the types of languages people kind of look at. But as a Python developer, I don't know how much you're going to interact with it. And maybe we can kind of dig into that a little bit. What do you think about the initial premise of the question, Chris?
Hype is always one of those hard things to talk about, right? It's particularly when you're in the middle of it, it's often hard to know whether or not it's hype or not, right? I managed a team of Ruby on Rails developers. I don't know that I would have considered it hype at the time. It was one of the better tools for doing what we were doing because most of Ruby's use was Rails. When other web technologies started popping up, it kind of faded because people switched to the more recent web technologies.
Can you give a time frame on that?
It's at least a decade ago, if not longer.
Okay.
I'm old enough that that's vague. It's in the past, pre-COVID. This is my entire timeline now. Before COVID or after COVID, it was definitely before COVID.
The before times.
And that's not like a statement on Ruby. It's not a statement that it shouldn't have won or should have won or whatever. It's just sort of the reality of programming languages, and sometimes the better one doesn't always win. So it's really kind of hard to know what is and isn't hype. And quite frankly, if it wasn't for Python's breadth of things like data science and machine learning and some of the other stuff, we might not be talking about it as much as we do now, right?
Exactly.
So it's often hard to know how these things will go. So I find not that hype doesn't happen. I just find it's very hard when you're in the cycle to know, is this something, are we still going to be talking about Rust 20 years from now? I don't know. There are some signs though, right? It's inside of Firefox. It's inside of Linux. It's being used a lot in Python, and a lot of Python programmers are going to it, like you said, for speed answers. Well, Python is routinely the first or second most popular language out there. So just on the fact that a lot of our folks are using it might be what gives it that leg up, right? So it's hard to know from that perspective. The other thing here is, I hear people talking a little bit, it's meant as a replacement for languages like C. And there's a challenge when you're doing that, because one of the reasons we want to replace languages like C is because of problems like memory safety. I've heard people say that Rust is harder language to pick up, and that might be where his sort of meh response comes from, because he's already a C programmer. So he sort of looks at it and goes, why would I do this?
Yeah, why would I learn this new thing?
But the problem with that is, that there's a higher learning curve to this language because it takes care of some of those problems. So the initial learning curve on the language might be rougher than, say, C, but then you can't make certain kinds of mistakes that you will spend forever debugging or watching your programs crash in C. So it's kind of hard to know, right? Like that initial learning curve is rougher, but the productivity you have with it might actually be higher. So those kinds of things are hard trade-offs. And quite honestly, until you've got personally, I guess if I don't have 2 or 3 years of the language under my belt, I don't think I'm qualified to say yes.
Yeah,
I would pick this over that, right? It starts to become problematic.
This article digs into some of that in the sense that there are a few of these developers were looking at C or working in C, and maybe spent a couple months revising a version of the tool that they were creating in C, and then decided to switch to Rust. And in many of the cases, again, this is not, your mileage may vary, they were able to rewrite the code in Rust. And again, this maybe is that weird crossing point of like, how much time is spent in learning the language versus how much time are you spending debugging and fixing your code and making sure that it's running properly. And so, when you get into actually building things with it, maybe there might be a larger initial investment. I have not messed with it. I haven't done C in so long, and I haven't really built any tools with it. But it's an interesting community. I mean, Rust, the things that people think about, again, that it's very fast and memory efficient. It's makes parallel and concurrent programming easier from what people are saying. It has a happy community, which is an interesting thing for people to write. It has good tooling as far as I think there's systems called Cargo, right?
Yes.
For the whole library stuff, which is, again, people seem to be pretty happy about it. And they call the compiler friendly. So it definitely has some advantages there. And that's always kind of a community thing. But yeah, I mean, your mileage may vary. Like I've talked about R on here multiple times as a data science person, and I like certain aspects of it, but I'm not looking to do all my programming in R. There was only some specific sort of data cleaning and so forth that it was really suited for. And so it's a tool that's suited for, in my opinion, tooling. It's really great at that, like the things like creating a linter and speeding up these sort of lower level things that, again, what's great is we reap that benefit of all this work that's being put into it in the same ways that we used to with C and some of these other languages in the past. But Rust seems to be where a lot of the energy is going. So I don't know about the hype part of it. It's a hard thing to measure. I know that when I was starting to get back into programming, again, this is right about a decade ago, like you were talking about, Rails was one of these things that I would hear about. And, if we're going to measure hype, I definitely saw lots of articles and podcasts and things about it at the time. And, most of it sort of dropped away.
You should never trust the podcasts. Nothing but misinformation on those.
Yeah. So in the same way, I haven't been out looking for the Rust podcast and so forth. I guess I got to, that's something we'll start here.
But it's got a relatively strong integration with Python. So the PyO3 library allows you to go both directions. You can call Python from Rust and Rust from Python. And in fact, we're linked to a project recently in PyCoders called Rust Python, which is a Python interpreter written in Rust. And one of their drivers behind it is it allows you to embed Python in your Rust programs. If you're trying to build like a GUI tool or something like that that needs some flexibility, let's say you wanted to build the next Excel killer, because wouldn't we all love to?
Yeah.
And you need some speed there. So you could write it in Rust, but you could have the programming language for your ifs in your cells could be Python, and that allows you to embed Python inside of it, right? So there's some flexibility here, and because there's a fair amount of crossover from some of the hardcore maintainers, the writer of Rye is also the writer of Flask, right? Like there's a tight Venn diagram in these worlds at the lower ends of the Python community, and so I think we're seeing it a lot within the Python space, possibly more than elsewhere.
Yeah, so we'll include links to PyO3, the Rust bindings for Python. I'll include a link that talks about Rust being used in Linux, and then also the Rust Python thing. I have the page for it up, and yeah, the idea that you could kind of write in Python and get the scripting ability of that and sort of the speed of development, and then get sort of the speed of Rust, but then the bonus of maybe deploying it via WebAssembly or what have you. So there's lots of interesting things kind of happening there that kind of tie these things together. I feel that Stephen's thoughts are not alone out there. I know that there are other people that are maybe feeling something similar. I feel like there are backlashes to lots of these types of things happening across it. It's just like when things become more popular, there's always backlash that kind of can happen one way or the other. But as a tool, and I can definitely at least give you some evidence of the reasons why and what's happening with it, and reasons for its popularity, and definitely can see how it works inside of this community to be a great tool for continuing building and speeding up Python. And if anything, you're just going to benefit from it. You're not even having to learn how to program in it, which is kind of great. again, thanks again, Stephen, for writing to us and asking the question. And I want to let anybody out there who's interested in bringing a topic to us, to either for a discussion or there's a particular article you would like us to cover, please send us feedback or send us a topic idea or send us a discussion topic. You can just send it to podcast@realpython.com. And I can't say we'll cover all of them, but we will do our best and definitely will read all of them. Along with that, if you prefer, you can reach out on Twitter or Mastodon. You can definitely flag us on there, the Real Python accounts, or we'll include our social feeds on the bottom of the show notes this week. So you can reach out there if you'd like to follow us or send us notes on the different platforms.
I think you're supposed to say like and subscribe. Isn't that how this works?
Yeah. I think it's follow instead of subscribe. I don't know. Smash that button. All right. So let's get into some projects. What do you got this week?
Yeah, so I'm starting with django-mock-queries, and this is by Pythos Styliandis. I'm probably screwing that up, but my apologies, sir. When you're dealing with the database ORM in Django, you use what are called query sets. These are abstractions to running an SQL query in the database. And they have this nice little property that they're lazy. They don't get run until you actually demand the data back. That means you can chain them together. So let's say I'm going to back to my people example. So I'm filtering on people with a first name beginning with F, and then I can run another filter on top of that query for people with the last name beginning with J. Now, that's a bad example because you could do that with one filter, but you get the idea. You can chain things together. So this mechanism allows you to do things like dynamically create filters based on what users put in on the website. And you can do incredibly complicated queries, anding and oring things together, different parameters. And then you can even do things like aggregating the results, like summing up one of the fields in the results. So I've got that list of people. I'm going to add together all of their birth dates, which would be weird, but sure, you can. So what the Django-mock-queries libraries does is give you an interface that works exactly like a query set, but on mock data. So you can dynamically create a mock model and create sets of them together, then run the exact same filters on this mock data the same way you would with a real query set, including that aggregation stuff. This is really handy for testing scripts. If you've got complicated filtering code, it's much faster to test if you're dealing with mock data. And it means you can quickly hard code some values in your tests without having to set up actual ORM models. The README for the library is actually pretty decent. Pythos even provides a pretty exhaustive example of how you could use this to do testing. So it's a neat little library for those of us who work in this corner of the Python world, and it might be worth for you to check out. And as I don't think I've shamelessly plugged my Django book yet in 2024, I'm going to use this project as my segue into shamelessly plugging my book. We've just recently dropped 2 more chapters into the early release program. One's on APIs, the other's on HTMX. I've also just got back my 3rd set of internal reviews. Manning, my publisher, does an exhaustive review process to help authors polish their content. And I'm happy to say I got an aggregate 92% score, so it's being well received. So anyone who's listening who's already on the MEP, thank you. Make sure to get your latest copy. And if you haven't got a copy yet, I'll bribe Mr. Bailey here into including a link in the show notes.
What's the title again?
A Django in Action. While I'm on the topic, thanks to all my reviewers, early access readers, the feedback's been fantastic, and it helps me create a better product, and I appreciate that. So
sweet.
So enough about me. I'll relinquish the mic. What's your project this week?
So my project is for anybody who's been scratching their head wondering what is going on with requests in Python. And requests has been sort of feature frozen for a while. In fact, if you go to the PyPI page for it, you'll see like the last update for it was, I think, last May. A few different authors have been creating libraries. Christopher mentioned another one to me earlier that have been looking at requests and thinking, well, what can we do? And this is by Ahmed Tari, and the title of the project is niquests, Niquests. The subtitle being requests but multiplexed. And niquests is a simple yet elegant HTTP library. It's a drop-in replacement for requests, which is under feature freeze. niquests is the safest, fastest, easiest, and most advanced Python HTTP client. That's their quote. So again, the idea here is you're going to have a really similar footprint sort of drop in here, but it ends up giving you lots and lots of additional features on top of it and stuff that you may want to think about. I'll include a link to an article that talks about why you may want to switch. It's 10 reasons you should quit your HTTP client. That's by Ahmed also. It's actually got some really nice documentation to get you going. Reasons you may want to move beyond requests right now. Being able to do HTTP 2 by default, HTTP 3 over a QUIC. It's multiplexed, it's thread safe, async, DNS over HTTPS, DNS over QUIC, browser style TLS and SSL verifications, sessions with cookie persistence, keep alive and connection pooling, international domains and URLs, automatic honoring of .NET RC, basic and digest authentication, familiar like cookies, network setting, fine tuning, all kinds of really great stuff. Again, sort of modern features. When you're talking about the web, it just keeps moving. And unfortunately, requests is kind of stagnated, unfortunately. One really interesting thing is that it looks like there's some sponsorship happening here through a Tidelift subscription, which is great. I hope that helps Ahmed keep the project going. Check it out. I played with it just for a few minutes, and I think it might be a nice drop-in replacement for requests. There's some other ones. The one you mentioned was what, HTTPX?
Yeah, that's the one I've used a little bit. Not much, but I have used it. And it's the same thing that's based on the same API as requests. So if you're used to using requests, it's not a hard lift to get there. And it was pretty decent.
Nice. All right. Well, Christopher, thanks again for bringing all these articles and projects this week.
Always fun.
All right. Talk to you soon.
Cheers.
And don't forget, go to sentry.io/resources. That's sentry.io/resources to register for the workshop Taming the Kraken on February 28th or on demand in March. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.